Hello everyone and welcome to our webinar about Naviate for Civil 3D piles and sheet piles. There are three of us here today: Martin Olsén, Thomas Nilsson and Caroline Tigersjö. So we are going to look into piles and sheet piles. These functions are in the Naviate Road panel. By the way, Caroline, are we recording? Could you please handle that? As I said, it's on the Naviate Road panel. It requires a Naviate Road or infrastructure license to work. So these functions here for the most. And we are going to, so let's see, yeah, there. We're going to look at piles, creating sheet piles, line columns, and different stuff there. We're going to look into sheet piles, how we define those, and also anchors. So these have different sub-menus in there. There are also some settings in the technical drop-down there, mainly AutoCAD settings that apply for different things. Our plan is that Martin will demo piles and line columns, sheet piles and anchors, and walling. Thomas, me, will later demo property set analysis, profile view support, and piles from Kogel points from CSV5. And Caroline will be answering questions. Okay. Martin, over to you to start. Thanks.
So, thanks. My time to shine. And can you see my screen now? Caroline and Thomas maybe can answer.
Yep.
Yeah, great. So, let's get started. And thanks for the opportunity to join you, Thomas and Caroline, in this tech session. So, we will start off with those line columns. And I have prepared some surfaces and styles here. As you can see, we got an existing ground surface, we got a rock surface, we got a surface for the foundation here that I will show the piles functionality later on. And we also got a datum surface for road that I will use for those line columns. So I jump into the Naviate Road model and go into piles function, and here I can find the create line columns. So I pick that one, and I get up this dialog box. And first of all, I can give this group of column piles a name. So I call it road columns, just simple as that. If I want to, I can also add a description. And here I can see what layer these columns will be in. And the basic setting is NV, not the line columns, so I don't need to change that. And if I want a prefix in the layer name, I can just check this box that says add group name into layer name. I also have a tick box that I can have checked if I want to remove the columns in this group, but I will show that later. Next, I got the settings for the columns, what number they should have. I can also add a label to these columns if I want to. I got the size, diameter for the columns, and in the beginning it's 0.6 meters. And then I got what interval I want in each row and the spacing between the rows. And if I use this polar line that I will show now, I can also choose how many columns I want it to be in every row. So I'll change these values, and I want 6 columns in each row, with a spacing of, let's see, we take 4.8 and interval 2.4. And we also got the settings here, triangle layout and a phase shift on each row. And this phase shift makes every row shift a little bit in the plan area. So you will see when I create them how they will look like. And then I choose my top surface, and I will use this datum for road and the rock surface. And when I'm done with all my settings, I just press OK. And then I choose what the line I want to use as reference. So I pick this middle of row line or center line. And then it will start create those line columns. And I can nudge the graphic if I want to see them be created. And then I can just sit back and waiting for the command to finish. And when they are finished, I'll see all my line columns here. If I want to change something here, I can just run the function once again. And I still got this group name. And now I can use this tick box, remove previous columns in the same area. If I want to remove all the old columns and change my settings, and then I can just run the commands again just by hitting OK. Select the polyline once more, and now you can see all the old columns is deleted, and it will create new columns for this area. So you don't need to erase every columns by yourself. You can just run the command once again, and it will recreate all the columns. So that's how you work with line columns for polyline. If you got a closed area like this, you can use this command as well. So I will call this group name. I will change this to row columns 2. And when I use these areas instead of lines, it's just the spacing between the columns. It will be the same in X and Y lead. So the only thing I need to change here is this spacing between rows. So if I pick 4.8 here, it will create those columns with those spacing in both ways. And the number of columns doesn't matter either. It's only when I follow a line it matters. So here I can change the top surface because my row datum ends here with this line. So I change this to existing ground surface and press OK and choose my area. And waiting for the command to be finished. And here I can see how it's created with 4.8 meter in both directions. And here I can also show the phase shifting. I can see we've got different places on each row. So every second row it will move places on. So simple as that is how the line columns function works. So if we jump into the piles functionality instead, you can of course also create line columns with piles if you want that. First of all, I will get my reference points. So I run the xref command and just attach this DVG where I got my points. And then I use the bind command and insert to get the points in this drawing. And you can do any insertion at once if you're comfortable with that, or just copy paste from another drawing. To be able to see those points a little bit better, I will just change the p-type style. So I will have a X mark and set the point size to 0.25 and in absolute units. So, and when I do this insertion, it will come in as a block. So I will mark that and run the command explode. So I get all those points free. So now when I got my points, I will create the piles from the points. And this is just a regular AutoCAD points. And I will zoom in to the construction area here, where I got my foundations, and I can see I got these points with an elevation in the foundations. And I will also change some views here, change to conceptual, and my layer states it will be a bit easier to see here. So I'll hide most of the K construction elements. Like I said, it doesn't work, but you can just go and turn those layers off in here instead. So now we got a little bit better view when I create the piles. So first of all, I will just create the piles from those points. So I run the piles command, create piles. Get up this dialog box, and I can call the first group point piles. It's pretty much the same settings as in the Lime columns. I can add a prefix to the lane name. I can delete prior piles if I had create some earlier. Then I also got the pile number. I got slope if I want to set a slope factor in here. Diameter, choose what diameter the piles will be in, and here I'm just free to change to whatever I want to. If I want to extend the top, like if I have a top surface, I can just add one here to add 1 meter to the top, and same thing with the end if I want the pile to go into the rock bottom surface. And I can also choose what kind of profile I want to create, if I want to create a circle or a square. Then I just choose my surfaces, and top surface, existing ground, and datum surface, rock surface, and hit OK here. And then I pick what points I want to create the piles from. So, and now as you can see, the function did move up these points to the existing ground surface. And if I don't want to create the, if I want to create the piles at the same heights as the points when I use AutoCAD points, then I can use those points, just create a new surface. Just call this pile points, so I know what surface I need to use. And then I set the display styles to no display. Okay. And then I add those points I want to use in this surface as drawing objects, points, and I just pick whatever points I want to add. Hit enter, and then I can run this function, create piles. And this group I can call point piles 2. If I want to create or remove those piles, I can just leave the name here. Same again, pile number, and now I can set a slope. I will have a slope factor with 1 to 4 here, same diameter, and the same profile. But here, for the top surface, I change the surface to pile points, and then press OK, and select what points I want to use. And I can just drag over here because it will only select AutoCAD points anyway. Hit enter. And now when I choose a slope, I also need to choose a direction. And here, in this case, I will just write 90 degrees, and it rotates from east. So I write 90 here and hit enter. And I can see now the piles creates with a slope factor, and I also get the right elevation for the piles. And if I want to add more piles, I can just add more points. Hit enter, and it will rebuild the surface. And I can run this function again, create piles. Settings is stored, still got the slope of 4 here, and my surface. So I hit okay. But before I do that, I will also tick this checkbox, delete prior piles, and I will recreate those. Hit OK. Choose my points. Now I want all these points. Hit enter. And now instead of typing the angle or the direction, I will use the other alternative. So I will pick 2 points. So I pick my first point in the middle of the foundation, and then I choose my direction graphical, in which way I want the piles to be directed. And then it creates those new piles. If I want to use Kogo points instead of regular AutoCAD points, you must have made a function for that as well. So as you can see, I got this point group here called NV piles. And if I check settings, I also got a user-defined property classification, and it's called Naviate. And it's data you need to create to run this function. If you don't have this in your template, you can simply press the piles and then import Kogo point settings to import those settings files. And then you will have this point group, and you will also have these settings for pile from Kogo points. And then you can just run the points command to create or convert AutoCAD points to Kogo points. And I will pick these points. Hit enter and see all the points converted. And I will also change the scale so I can see what I'm doing. And here I can see the points. So to be able to create those piles, I will add those points to my point groups that is called NV piles. And you can create points from or piles from another point groups. But this is one point group that is included when you import. So I go to properties, and then I choose the tab include and with row description matching. And I just use the standard code here, PKT. You can change this code if you want to code the points in another way. And then press play. Oh, okay. And now I can see all the piles in these point groups. And here, when I run this function, it's called create pile from Kogo points. So I start that one, and I can call this group point pile 3. And here I got some alternative as well. I choose what point group I want to use, and I choose where the pile should get its number from, and it's the number from points. Top, I got this another height above point, and if I want the height to be a bit over the point, I can just add a height. I also got fixed elevation and height above surface area if we just want to use the position from the Kogo points. So it's kind of flexible. And I also got this alternative, same in the piles as in the other pile function. They can choose for the datum surface. So I'm still working with this rock surface, and then I just hit OK here, and it will create the piles from the Kogo points. And as you can see, you don't get any opportunities to choose settings like slope or dimension or so. It's because it's specified here in the property set classification. And here you can change the point. If you want it to be a circle or a square, you also change the size for the pile and the slope you want on the pile. You can also specify the direction here. And it's because we wanted to let the user be able to define those data in an Excel spreadsheet instead. And Thomas will show how it works if you get like data from a contractor instead. But he'll show that on later. So let's move on here. If I want to export those points as 3D polylines to a contractor surveyor for stakeout, we got the last function on piles, that is create 3D polylines from piles. So if I run this function, I can just mark the points or the piles I want to export as 3D polylines and hit enter. I can also choose if I want to include property data on those 3D polylines. If I don't want it, I just hit no. And I can see this 3D polylines is created. And when I got those, I can mark them and then run the AutoCAD command vblock. I just choose to save them on the desktop. Like this. And I got those 4 objects. And then I got them in a single DivG, so I can just send them to the contractor for outstake. So let's see which one it is. This one is it. Next function, we will look into the sheet piles. And we got some different ways to create sheet piles. I can use alignment, I can use a feature line, I can use a 3D polyline. In this case, I will use alignment. And I got a prepared regular 2D polylines here. So I will just create my alignment from that polyline by create alignments from object. Choose this alignment with that direction. And then I can call this sheet pile south. Type centerline will work. Alignment style, choose this proposed. Labels, I'll just use this major and minor labels. And I don't have any radius or curves, so it doesn't matter, but I can uncheck this box and then press OK to create my alignment. And I will also create a profile view because I will use that later on. So I start by using this profile tool, create surface profile. And I add this existing ground and also a rock surface. And I will change the style for the rock surface to rock here. Okay. And then I use this drawing profile view. And I will change this elevation performance to 1:1. And I don't need to change any other settings right now. I will just remove the data bands because I'm not going to use them. So I choose this no bands. And then I choose create profile view. And here I got my view of existing ground and rock surface. So we'll leave that for later. Now I will change this 3D view a little bit so you can see better. And I will start create my sheet piles. So I jump back to Naviate Road, go to sheet piles, and just this function, sheet piles. Then I use my alignment to get these settings. Here, once again, group name, I can call them sheet piles south. And I'm not going to add any prefix to my layer. Delete prior can be on because I don't have any other piles in this group or any other sheet piles. Next thing I want to do is to choose my profile. And here you can create your own profiles, however you like them. But we got some prepared, so I hit this bottom profile. And then it opens this folder NV Piles library in the support files. And I will use this L600 profile. So just press open. So I got my profile here. And here I can also choose if I want to mirror the first profile and if I want to add the blocks to insert on the top of every created anchor. So it will also mirror every second profile. So it depends what sheet pile you're using, but in this case, it will need to be mirror every second. So I have that one ticked. First number of sheet pile 1, spacing between sheet piles 0.6. And these are 600 or 0.6 meters profiles. So I will leave the spacing. This function is good to know about. And it's how many percent of the last sheet pile that will hit the line. So if we say, if I press 50% here, and if I only got 0.29 meters left on my line when it will create the last sheet pile, it will not create that one because it needs to be 30 or 0.3 meters or more to be created. I will show that as well how it works. Here I got start, end station, and then I set my height for the top of the sheet pile, and I will use this height above surface. You can also use fixed elevation. If you're using a feature line or 3D polar line, you can choose height above surface or height above line. But I will pick this height above surface, and I will just leave it 0 and use the existing ground surface. And the datum, I will use that below surface and continue using this rock surface. And I set this to 0. And when I'm happy, I just hit OK here, and it will start to create those sheet piles. And I can also see here from my profile lines, from my profile set created, how it follows the top surface or the existing ground surface and the rock surface where it creates those sheet piles. And the sheet pile works the same way. If you want to create them, just to run the command again, make sure you are in the same sheet pile group, and then just hit OK and run the command once again. And we hit go. And you can see I get this dialog box, how many sheet piles that are created. And if we look in the end here, we can see that it created the last one. If this line had been a little bit shorter, it hadn't created this one. And here is how many percent it need to be on the line. And we can see here it's over half of the length. So when I have completed the creation of the sheet piles, and I want them to be in my profile view here, I can run some special commands, Naviate commands, to filter them out by using this Naviate property palette and search for the NV piles property set. You can also take a look what data we have on those sheet piles and what I should use to be able to filter those out. So let's check properties, extend data, and I can see size. If I got them sloped, I see a slope, length, but I also got this group, so it should be the best way to filter those sheet piles out. So I close the property palette, and then I choose what group I want to work in. So I pick this sheet piles out, hit enter, and then hit search. And I can see it marks all my sheet piles. Then I use this select object and use set selection set A. Then I jump back to my profile view, mark it, and choose project objects to profile view. And I just use selection set A. And I can see all these sheet piles get highlighted, so I just hit enter. I won't put so much time in this. Thomas will show that as well. So I just use the standard style and no labels. Press OK here. And it's so many objects, so it will take a little bit of time to project all those elements into the profile view. But now it's done. So now I can look into my profile view and see in what elevation should I put my anchors in, and also walling. I will just do a simple example here. So I will use this level 30 to create my anchors and also my walling. So back to my plan view, and then I run this function, create anchors. And hit my alignment. And you should recognize this dialog box by now. It's pretty much the same in the top, but here we got some other settings for anchors that you can use. So first of all, group name, anchors south, name those. Check out this prefix for lay name, and I just have this delete previous anchors in the group checked. And here I can also see how it does a calculation how many anchors there will be in this creation. So first number, diameter of the anchors, spacing. Here I can change, and it depends what piles. If you want to have them in the middle of the piles, you can change the spacing. And here I will have 2.4. And you can also change the start and end station. I'll show an example of this later on. You can choose if you want to have an extra length on the top, and I want the anchors to stick out from the line. So I have 1 meter here. Then I choose what kind of top I want to use for these anchors. And now I don't have prepared a feature line or a 3D polyline, so I choose fixed elevation and hit 30 here. And datum, I choose length below surface, and I want this anchors to be going 3 meters in the rock bottom, and then I choose rock surface. I also got an alternative to choose what slope I want to create those anchors in. And I can also reverse this slope, but I believe it's like this for the moment, and create those anchors. So I press OK, and I can see how the anchors is created. And when it's done, I get the number of how many anchors that it created. So now you can see it started from the beginning of the sheet piles, and it's also in the wrong direction. So I just run this command again to fix those errors, picking the line once more, and it remembers the group name. And I will delete the previous anchors. So now I will change the start station to 0.3. So it will start 0.3 meters into the alignment. And I will also check this box, reverse slope direction. And then just press OK to recreate all those anchors. And now I can see I got a better position for the first one, and I also got the slope director in the right way. If I want an extra anchors or extra anchor, I can choose other function that is create single anchors. Just run that one, choose what line I want to follow, and it still remembers the setting from the other creation method. I will keep them in this group, but when I create a single anchor in the same group, I don't want to have this box checked, because if this box is checked, it will delete all other anchors, and I want to keep them. I just want to put out some single anchors. So I check this box, and then I just keep the other settings and press OK. And then I can give a station number where I want to put them, or I can use this alternative that is called point. and then I can just point graphical where I want my extra anchors. So activate the midpoint snap, so I will be able to snap in the middle of the sheet pile. I just press there. And now when I have put out my first, I can see I got this other alternative in the command line. I got distance. If I want to put the next one on a distance, I can undo this, or I can just hit create anchors to create that one. But if I create another, just to show, activate midpoint, and then I feel like I'm not happy with that one, I just press undo, and I still got my first one. So when I'm happy, I'm just choose create anchors, and the anchor will be created. So that's pretty much how anchors works. And what do you say, Thomas? Do we got time for the walling, or do you need the time we got left?
Yeah, do the walling, please. Please do.
The
I'll be
walling.
quick.
I always fail the walling, so I was hoping to skip it, but
Or as we call it in Swinglish, hammer ribbon.
yeah,
Hammer band. Hammer
it's a
ribbon.
bit confusing.
That's the walling.
But but at least I hope it will show what it is.
Yeah.
Okay, I will try to do it. Don't laugh at me. We will use this extrusion function. But first of all, I will create a profile for the walling. So I jump back to home ribbon, and then I choose profile and profile creation tools. Choose my profile view, and I put up a name on this one, call it walling. Profile style, you can call it the design profile, and we don't need any labels there. Press down there and OK. And then I just choose this row tangents and use this elevation. Just a straight line across the profile, hit enter. And if you want, you can also do this in different levels. If you want more than one level of walling, also with these anchors. So it's lots of different ways to create those year constructions. And let's jump back to the plan view and see if I can create some walling here. So now I jump back to Naviate Road and use this extrude function. So I choose extrude along path, and then we can call this walling south 1, just to have a name on that one. And here you can prepare a layer. I haven't done it now, but if you want to have them in separate layers, you can prepare a layer for that one. If I have drawn a profile, I can just use a profile, but we have prepared some blocks here in Naviate so we can use. So I check browse, and then I go into the support folder, Naviate blocks, and then we've got UP blocks for a UP beam, and I will use this 360 beam. Just press open, and here I get a preview for the insertion point where the beam will be inserted. So it remembers some settings I did last time, so I will just change those one. The rotation here is need to be 315 degrees, because it depends on which way the line goes. So I will just create this walling now, and then I will edit some settings later on. So I press create, and then I forgot a step that I need to do before I create this walling to have something to create from. Very easy. When you have this alignment and profile, you create a feature line from the alignment, because you can't create with this extrusion from alignment and profile, but it's easy to just create a feature line when you have the alignment and profile. So I run that command, choose this alignment, choose my walling profile, and then just leave the other settings. Press OK, OK. And now I have a feature line I can work with. You can also use this feature line if you want to work with anchors on that. So let's try again. Naviate road, extrude along path. I got my beam, my settings. So I just choose create and choose my feature line. And I want it on the top side first. So I press yes. So get on the other side. And here you can see to use the line as a reference, so we'll change some settings here. But I accept this, and then I go to extrude again, and I run this function, and then I choose edit. And first of all, I want to add an offset for the anchor. So I take half of the anchor, 0.0125. And then I also will add an elevation, so I can push this walling so it will be aligned with the sheet pile. And here you can just type a value if you want to and see where it fits. But we also got this pick function that you can use. So I will use that one, but I will update it first so I get it the right position with this offset. And then I choose this pick. And I will use two snaps here, nearest and perpendicular. And then I choose the back of the walling and the perpendicular point of the sheet pile. And I want to do the measurement in 2D first. And then I also want to divide the value by sinus rotation. So I hit yes here as well. And then I get the correct value in add elevation. So it's because it's need to be moved both in elevation and in plan. So now I just check update. And then I can close this. And now if I look closer into this, I can see it's in the right position for the anchors, and I also have them aligned with the sheet piles. And for the lower one, I just run this extrude again, extrude along path, and then I can call this number 2 and choose create. And you can see here it's all my settings is saved, so I can just run create and hit the line. And I don't want to flip it. So the second one I get in the right place from the start. It's a little bit hard to see here. So it is the first one that is a little bit tricky, but the second one will go very smooth.
Yeah, and everyone else you will do now, if you have the same size and the same slope of the anchor, it's going to be the same offset values. So this only needs to be done once per setup of anchor, sheet pile, and the walling.
Yeah, exactly. And just a little sneak peek here. How it can look like when you have finished your work with all the piles, sheet piles, and wallings, and the foundation. So it's good functionality. And it's about it for me. So now it's your time to shine, Thomas.
Thanks. You said that I had developed those functions. I didn't specify them, but these functions were developed by Pekka. I don't think Pekka is logged in today, no, but I do believe some of the attendees, you know. Okay, so first thing I'm going to look at is we had a question about exporting to CSV, and as Martin mentioned, to each of those objects here. So I have a mixture of sheet piles and anchors in this drawing. It's a 2D to the left and 3D to the right. And if I select one of these objects, you will see that I have the properties that Martin was talking about. So on that one, we have the information, what surface we used, which elevations and length, and the X, Y, Z coordinates of the start and end of the object. And also, as Martin showed, by using our property, our general property search functionality, we can search for any property set. It doesn't matter if it was added by us or by Civil or someone else. We can use this functionality here. And if I just click search, I'm going to get all objects that have that property set. But as also Martin mentioned, if I would only select a certain filter, for instance, for the group, I would only get those that in that group. Or if I want to go to which type it is, if I click that asterisk there, I'll get the used values. So I could, for instance, say I only want to see the sheet piles and search, and I get those. So very easy to analyze these things. I'm going to clear the selection. I click that one and I click search again, and then I get all again. I'm going to show the table functionality we have in here. So we have created a schedule table for this property set. It's included with the installation. So this one works with the NV piles property set, and it's got a schedule called NV piles. So these reports can be created or added by yourself if you want to. So I'm going to add this as a table. I'm going to place it there. So what I get is a long list grouped in certain ways with the type and the group name, and then it's information like the profile. Yeah, so I got a walling actually in here as well. And we see the length and size and so for each of those, and the sum at the end of this report. So these can be easily managed, and these are dynamic. So if you keep adding things or change things, these will update. The other question we had was about exporting. And yes, we can export CSV using this functionality here. And we have actually prepared for some reporting. So if I will be overwriting this CSV file here, let's do that. It's going to say, do you want to append to that or overwrite? I want to overwrite to that one or overwrite that one. Append means I'll add, so I can add in from different drawings into the same report. And what happened now was that in this CSV file, so let's see there, 1024, yes, I got a NV pile CSV. If I double click that one, I'll be in Excel, and here is all the information that we saw. So each of these is one object, either a pile, sheet pile, or anchor, or walling. And you can analyze that one. You can even edit that one, change values, and use the import back functionality. So we can import information back that you edited in that CSV file. What we also have is the ability, or we have prepared actually, in this folder where we normally place those CSV files, we have placed an Excel file that analyzes that one. So all I need to do is double click that one, and it's going to use that CSV file I had for analysis. And this one opens as it was the last time I used it or analyzed. If I click refresh, it's going to import the new export I did. So you will see that this one changes a little bit. I think yeah, we see that some values change here. So in here I can do analysis. If I know floor tables, I will be able to look. If I have multiple drawings, I will have abilities to look at the drawing or filter on the drawing name. These are the different instances when I created these things. So on each what should we call it, operation I do. So when I create different things, we add a timestamp to when we did it. If I filter on that one, we can see that 20 minutes past 7 sometime I created these walling there, and at another time I created was another walling probably. There I created some anchors at that time. So we can do a lot of filtering in here. We can filter using the groups and the times and so, and of course depending on how I create these filters. So here we can do a lot of analysis. I'm not going to focus more on that one. On my list, I also had to look at the profile reporting. So we've had, you see I've created sheet piles in this one, and I have a profile view in top here. And as Martin showed, we can use the profile or project objects to profile command. I will just select those and project here, there. We did some features in order to be able to create reports in the profile as we have heard customer requests. So when we set up this drawing, we import some stuff into here. We import a specific piles label. Notice that that one says copy text contents from description. And this is due to a bug in Civil. If the Civil imports labels that uses property sets, it ruins them. So you can see it says a bit strange here, PS, a number of characters there. And this is due to a bug in Civil. That's why we placed the actual report code here, because that one comes in. Okay. So we need, unfortunately, to do this once in every drawing, just once. So and now I've pressed Control C instead of copy. I'll have to redo it. Copy and paste there. And now it says it's pointing at my piles property set. So now this one will work. Unfortunately, this has to be done once in every drawing. But now when I click OK, I'm going to get these labels in here. Right now, they don't show the information I want to have. I want to have the piles number and the length. And that's because the data is not on the profile part. So we created the profile projection. So we created a command that would copy properties to projected objects. So all I now need to do is to select those objects I want to update. So it's the projections. So the projection objects now look at the original object and we get the information there. And now it says that this pile is number 1 and the length of that one, and we keep on here. I'm going to show a workflow also. If I would now like to modify the elevation on that one, maybe I say that that one I want to have 2 meters long. I do that, but as you see, the only thing that changes is the value there. So the workflow now is to push this back to my original object. So push that value I did back to the original object. And then I'm going to use a feature in here. So if that one wasn't very visible, we can see that I can select an object and I can also right click in here and do zoom to source, and it's going to zoom that one. There it is. I'll select that one, and we can now see that that one now says 2 meters. So what I need to do is go to the design of that one and change the height to 2. And now you will see, as soon as I leave that one, that it updates there. So that's the workflow. We're looking into maybe getting that workflow to be in one button. But this is the possibility that we have today. And imagine also the edit that I mentioned, being able to edit in the Excel file and open the information back. That's also going to make this a versatile way of editing elevations. If you, for instance, have surveyed the depth after you used this information in the site. Last thing I want to do is to very rapidly show the ability to use an external CSV file with information from a contractor about files. So the workflow now is to first use our command to import Kogo point settings. So what's going to happen in this one, so this is a brand new drawing. So I got a point group called NV Piles. I also got something called a user-defined property classification called Naviate, which has size, profile, angle type, slope, length, and direction. So using that, I will now use ordinary import points from file, and I'm going to pick a certain file that we got from a contractor. That is a standard in here. If I just edit that one, we will see that that one includes pile number, XYZ, slope, X to 1, and bearing. And this is each of those. So I'm going to select that one. What we also imported with that function I started with was a specific file format, point file format. So we're now importing easting, name, northing, easting, elevation, slope, and direction. What I need to now do is to add it to my NV Piles point group, because I want to have it in there. And the interesting thing here now, because the magic is that as this one now has the classification Naviate, it means that when I pick NV Piles, at the end of this here, I have direction, length, profile, and some other things which we can use in our function. So let's have a look at this here. Also, I want to show, you see I went from 2D to 3D and the points disappear. Some people I've heard say that, oh, it's not possible to see points in 3D. It is, but in most cases, the standard style has the marker turned off and the label. Now we see that they're there. So I'm changing the scale. There we are. Let's go to the Naviate Road ribbon and end this demonstration by creating piles from Kogo points. And we're going to use the point elevation, and I'm going to, I don't have a length, so I'm going to go to elevation 0. I believe that's what I need now. There they are. So that's the information from the contractors, allowing us to create 3D piles from their information. Okay. I don't see any other questions than the ones we've answered. We are very interested, if you that has seen these presentations that me and Martin have made, give us your thoughts about how do you find these things, these features? Are they interesting to you? Would you like to maybe have some consultancy about how to use these, or do you have addings that you would like to suggest? Why don't you do this? Why can't we do that? And so please feel free to contact either me or Martin, and we're interested in discussing more and helping you get starting with these features. Okay.
To start using this function, and sorry Pekka for not mentioning that you was the developer for the functions.
No worries, no worries. Okay, please give us your thoughts about these features. Any feedback is welcome. Okay, thank you very much, and see you on next webinar.